Welcome to another problem that we'll be solving today. This is a Leetcode problem which I hate, and I guess many of us do, because it's not really tests your problem solving skills or prove anything for the interviewer or the company, but just in case someone asks you this, you should know how to solve this. So this is a very interesting problem where you have to use a math trick basically. So there's a formula in math where you have a number, its power, and then that is basically equivalent to having square of that number to the power of n by 2, which means the power is divided by 2, and that is given as power of x. So without discussing too much about the math details, let's try to think about what's happening. We have two inputs given. First is x, the number x. Then we have the power, which is n. So why do we we can obviously use like math.pow function from the Python libraries or any of the languages that you might use, Java, JavaScript, or whatever. Every math library has this math.pow function. But obviously, because you are giving an interview, they are not expecting you to call some standard library function which defies the point of giving the interview. What could be the way of solving it? So if you know about the powers, like how power is written, so let's say I'm finding let's say 2 to the rest 6. So the power is in actual converted to 2 to 6, and then it's basically 2 multiplied by itself 6 times, 4, 5, and 6. So this is what we do usually. So we can do that, but imagine the power is, let's say, a crazy big number, like I don't know, any big number like this. So imagine how much time we'll be spending doing these calculations, and it's kind of inefficient. So we won't even talk about that solution, and instead let's focus on this math trick or math formula. So what the formula says, like x raised to n is equivalent to its square raised to n by 2. So if you have to find x raised to n, we can basically take its square and then divide the n by 2, which would be dividing the power number into half, which is pretty efficient to calculate, because we are dividing the larger part of the calculation into half every time we do this calculation. That's theory. How do we solve it? How do we write the code for it? So I guess we can write a function where we can keep on dividing the number or keep on squaring the number and keep lowering its power by 2, like I said. But before that, what if we are given with a value that is smaller than 0, like a minus value for the power? So I guess we can there's another metric here. So if any power of the number is a minus value or a negative value, we can actually convert the number itself, like of which we are calculating the power of, to a decimal point, and then the power can be turned positive. So if I have a number, let's say 5 raised to minus 6, so I can write it like this: 0.5 raised to 6, which is basically the same thing. It just makes our calculation logic easier. So let's do that. So if n is less than 0, then simply what we do is x is equal to, like we said, we need to divide it by 5, not 5, I mean 1, and then our power becomes positive. So how do we make a number positive? We can simply multiply it by a minus 1, which would give us a positive value, so anything into -1 is positive, right? That's cool. Now what we need to do is basically take the square of the number. So we say x square, or let's say we simply modify the value of x in place. So square is nothing but multiply the number by itself, and then we said we can power the or we can divide the number by 2. So we say number by 2, and yeah, it's divided. But remember, we also need to find the power of this result power to this result. So for that, we can actually implement it this way, that unless my number is reaching to 0, we can basically continue doing the same thing. So let's say we have a number 30, and or let's take a small example. Let's say we have a number 3 raised to, let's say 4. A simple example to understand. So what we'll be doing in the first iteration is we'll be doing a square of this number. So 3 raised to 3 is equal to 9. 3 into 3 is equal to 9, and then we are dividing the power by 2, which would be 2. So again, we have to do 9 raised to 2, which would give us a final answer. So it will be 9 into 9, which is 89, I guess. Not 89, 90 minus 81, yeah, 81. And then we have 2, so again 2 by 2 would be 1. So 81 power to 1 basically means 81. So this should be our answer, the final result. And because we reached 1 already, we are left with the final answer. So whatever the value of x would be at that time here, we can return it. So return x here, and now we need to write that loop. So while n is greater than 1, we need to do this, because every time we are dividing it by 2. And but what would happen if our value is odd number? So in this case, let's say the value is 3 here of n. It can happen, right? So instead of having 4, we could have something like 5 or 7 or 56, or not 56 actually, but 55 maybe, right? So we need to handle that case. So how do we check for the odd number? So we check if n mod 2 is equal to 1, which means it's odd, and in that case we can reduce the power by 1. But because we are reducing the power by 1, we also need to update our value for the same thing. So what we need to do is it will be x into x here, and now we know the power is even, and then we continue with this thing. But I'm probably missing something here. Let's see what that could be. So I have x. If I'm seeing that my n is less than 0, that means my power is negative. So I'm basically converting the x, which is the base, to a decimal point number, a float basically, and then I'm converting my power to a positive value. Fine. So until my n is greater than 1, I'm going to my loop. If my number is odd, then I'm updating my number to its square, and then yeah, basically this thing. Yeah, I guess I should do it, but let's try our flow. Usually I walk through the code and try to verify line by line, but let's try to run it now. I'm sure I'm missing something. Yeah, like I said, the output is quite different. So in this case, I guess I have solved this previously, and then let's see what was my solution. Yeah, I just did that before some time. Right, so the actual solution should be like this: if p is equal to 0, return 1. I guess we haven't done that, but let's do that. N is equal to 0, return 1. Then n is less than 0, then we converted our number to our power to positive, then we divided our number by 1, which is 1.0, which is, I guess, the same thing. And then we said when power is not equal to, oh actually yeah, we need to maintain a separate result for something called binary exponential, which is basically adjusting the power. So instead of doing this x, I need to do that with result, and the same thing, I guess. Instead of returning x, I need to return the result. Right? No, still something is wrong. Let's see what's that. Yeah, I guess I need to do it until n is not 0, which is, to be honest, same as previous, but yeah. Actually, let's check this line by line. If p is not equal to 0, then we need to return 1. I mean, p is equal to 0, then we need to return 1, because anything power to 0 is 1. And then we have, if n is less than 0, then we are making it positive, converting the number to a decimal point. Result is 1 initially. We have this loop where we say if my power value is not equal to 0, we continue the loop. If the power is odd, then we multiply the number with result. We decrement our power by 1 to make it even. Then we have our number, make power of 2, x square, I mean. Then we divide the power by 2. Yeah, it looks pretty much the same. Okay, so it looks like for a particular condition it's failing, which is if my power is -2. So let's see what's wrong with it here. So that's this case. By 2 is equal to -1 into p, which is n for us. Number is equal to, oh, actually we have did it opposite. Okay, so it should be like this exactly. Yeah, so we were dividing it in opposite order basically. Yeah, that's passing. Let's submit it. Right, it's 100%, and this is not very intelligent thing, but I guess it's just for the sake of doing it. Just this is the solution, and as you can see, we are doing it in log n. Like I said, we are dividing the power by 2 every time, so we are reducing the calculations by half every iteration of this loop, and that's why it's a log n instead of n, and we are not using any extra space, so our time complexity is log n, and then we have our space complexity as 1, because apart from using this helper variables, we are not using anything else. Let's also look at the editorial here, which I believe they have given the same solution. Yeah, same thing. Log n, space complexity, recursive step most. Okay, looks like they're using recursion, but in our case we are just doing it iteratively in a loop. Yeah, I guess they have the solution as well. Yeah, like I said, log n and O of 1. That's it. Yeah. Thanks for watching.